The world has always been full of invisible forces. The wind doesn't announce itself, it bends trees. Gravity doesn't speak, but it holds the mountains in place. Light, motion, heat, all in silent harmony. But even in that silence, there's a language, a pattern, a rhythm, and one day, humans began to listen. We realized these forces don't just exist. They affect us, they move us, they shape our lives. And to survive, to thrive, we needed to model them. Two kinds of thinkers emerged. The physicists, the seekers of reality. They look at the world and ask, why does this fall? And why does that spin? They create models inspired by guesses about the truth. Mathematicians, on the other hand, are system builders, the guardians of structure. They don't ask, why does the apple fall? They ask, how to prove that the apple will always fall? They ask, does this idea scale? Does it hold across time and space? The physicist dreams, the mathematician validates. But both rely on one shared language, mathematical operators. These operators were not made for classrooms. They were invented to compress ideas, to uncover relationships that are invisible to the eye, to model reality in ways we can test, scale, and trust. Let's look at some famous operators, starting with variables. X, Y, and Z, the most famous of all, the most famous placeholders. They hold the unknown. And in AI, X is the input, that is your data, and Y is the output, your prediction. Enter the derivatives. Derivatives tell us how fast things change. In machine learning, they power learning. They help the model adjust and to learn better. Sigma. Sigma means sum it all. It helps models compute the total loss or total cost of being wrong. Pi. Pi is about multiplication. Pi as a symbol denotes continuous multiplication, useful when combining independent events. Enter the set notation. Set notation helps define the idea of belonging. Does a certain data belong to a group? What is in? What is not in? It's actually logic made visual. Then comes the functions. Functions are the operators which builds the relationship between the variables. Functions map input to output. It's the core of how machines learn. Input goes in, prediction comes out, and the function that makes the prediction come out from the input is usually the AI model. The norm. Norm tells us how big or far something is. They're used to measure size, error, or distance. Dot product or the inner product. Dot product tells us how much two things agree with each other. Dot product is at the heart of attention mechanism in AI. Argmax. Argmax let us understand, out of all possibilities, which one is the best. Argmax gives us the final answer, the most likely label. These symbols aren't magic. their compressed thoughts. There are many, many more symbols. They are there to simplify your abstraction of the system. Behind every AI model, behind every prediction, lies a quiet army of operators doing the math. Understanding them is like seeing the matrix. So don't be afraid of mathematical operators, because nature is still whispering. And if you learn how to listen with the filter of mathematical operators, you will not just understand nature, but you might just learn how to predict it.